Today we're going to look at sinusoidal waves and the tangent curve. So we need to go through some definitions, and some of these definitions you may know. A period is the horizontal length of the shortest interval in which a graph repeats itself. So when we're dealing with waves, we're really talking about a wavelength. How long does it take for the graph to repeat itself? And by the way, the word period is often used to describe things that happens in cycles. And you may know like the periodic table. So it has a very distinct pattern that it follows. Also, periods in hockey. Wavelengths are also described, or waves are often described as periodic. They happen, they repeat over a certain interval of time. Now, the word amplitude, moving on to the next definition here, amplitude is a measure of the height of the wave. The amplitude is half the vertical distance from the crest to the trough of the wave. Now, the crest really means the top, the trough really means the bottom of the wave. So half this height is known as the amplitude. Alternatively, the vertical distance between the middle of the wave, the median of the wave, and the crest or trough is also the amplitude. All right. Using our special angles of previous work, so right now take out your sinusoidal charts in which you have various angles and you have the sine, cosine, and tangent values from negative 360 to 360, or I'm going to actually do negative pi or negative 2 pi to 2 pi. Take those out right now. It'll help you out. So we'll be considering several properties of the graphs. So we haven't made a graph yet, but these properties are going to help us understand periodic functions. Periodic functions, so incredibly important in physics. So we're going to talk about amplitude, the zeros, the period, the locations of the maxima, the locations of the minima, and the y-intercept. So we are just going to start off by graphing y is equal to sine theta. Along the horizontal axis, we'll have theta. Along the y-axis, we'll have the ratio of sine theta. So, for instance, we know that the sine of, well, I'm not going to do degrees. How about I do the sine of pi over 4? Now, that is equal to 1 over root 2, right? And 1 over root 2, I forget. I believe, now I feel on the spot here. I believe it's 0.7 or 0.8, so it's pretty close to 1. So if I know this, I'm going to graph the point theta, comma, y. Or specifically to sine theta, I'm going to graph a coordinate point as theta, comma, sine theta. Let us begin. I'm going to set up my graph. Along the horizontal axis, I'm going to graph from 2 pi to negative 2 pi. Now I'm going to count up in pi over 4 intervals. The reason why I do that is so that my intervals are evenly spaced. So, and then I am going to mark my vertical axis with 1 and 1 over root 2, negative 1, and negative 1 over root 2. We know that the sine of pi over 4 is equal to 1 over root 2. So that will translate into my function having point pi over 4, 1 over root 2. So let that be my first point. Now, I also know at the angle pi over 2, that has a sine value of 1. So pi over 2 has a sine value of 1. So far I have exactly 2 points. So now I'm going to maybe consider 3 pi over 2. Nope, sorry, incorrect. 3 pi over 4. That would be my next thing. 3 pi over 4. Well, 3 pi over 4 has a sine value of 1 over root 2, which is right there. Now, pi has a sine value of 0. So there we have it. I have 3 points on my graph. I can go for more. For instance, the sine of 0 radian is 0. So I also have a point 0, 0. So this is what the sine curve looks like when we're dealing with all angles between 0 and pi. As we continue, the angle 5 pi over 4, the sine value is negative 1 over root 2. When theta is 3 pi over 2, my sine value is going to be negative 1. When theta is equal to 7 pi over 4, my sine value is negative 1 over 2. When theta is equal to 2 pi, my sine value is 0. So this is what my sinusoidal wave looks like so far. You may be asking me, how am I pulling these numbers so quickly? But presumably you have that table beside you, or you have memorized the sine values for various angles. Now I'm going to go for negative pi over 4. Well, actually, I don't have any tables in front of me, and in all honesty, I have to think about these numbers fairly hard. What I'm going to do, though, is I'm going to exploit the periodic nature of the graph to get these other points, in my mind at least. Don't worry, I'm still going to talk to you about this. So when you look at the table, negative pi over 4 has a sine value of negative 1 over root 2. Negative pi over 2 has a sine value of negative 1. Negative 3 pi over 4 has a sine value of negative 1 over root 2. Negative pi has a sine value of 0. Negative 5 pi over 4 has a sine value of positive 1 over root 2. So what we notice here now is negative pi over 3, or negative 3 pi over 2 has a sine value of 1. Negative 7 pi over 4 has a sine value, well, I stopped talking, right? And what I did for those last 2 points is I just sort of followed the pattern of the graph. I could look at the table and say, oh, negative 7 pi over 4 has a sine value of 1 over root 2, and negative 2 pi has a sine value of 0. But what we see is this pattern. So this is what is known as the sine wave. Sine wave is really, really, really interesting. So what is the amplitude? Well, the amplitude is going to be 1. If you notice, the vertical distance between the crest and the trough is 2. So half of this distance is my amplitude. Amplitude is 1. Or in other words, what is the vertical medium, or the middle of the graph? Well, it's going to be y is equal to 0. The distance from that line to the crest is also 1. So that's partly the amplitude. The zeros. Well, the zeros of this graph, if we take a look, they happen at negative 2 pi, pi, 0, pi, 2 pi, probably best described as k pi, where k is element of the integers. In other words, they happen every pi. Now, period. What is the period of this graph? Now, period means how far does it take, or what is the horizontal distance it takes to repeat the graph? Now, it's probably best measured crest to crest or trough to trough. This way, there's no real confusing. So negative 2 pi to 3 pi over 2, the period of the sine wave is 2 pi. That is, the graph repeats itself every 2 pi. The location of the maxima. Well, I know that one maximum occurs at pi over 2, correct? This point right here. And I know that there's only one maximum per period, per wavelength. How often does this graph repeat itself? Well, every 2 pi. Sorry. So really the maximum is pi over 2 plus k, or plus 2k pi, where k is element of the integers. Now, the minima, now you could write it as negative pi over 2 plus k2 pi, where k is element of the integers. You could also write it as 3 pi over 2 plus k2 pi, k is element of the integers. Let me split this up here. Now, my y-intercept, well, let me look at my graph. My y-intercept is 0. So, this is the sine wave. Have you encountered the sine wave before? Absolutely, you have. You've encountered the sine wave before if you've been in the water and waves come at you. There's a crest, and then there's a trough. And there's a crest, and there's a trough. If you've ever been on a Ferris wheel, you know what this feels like. You're in the middle, and as you get towards the top, it slowly goes towards the top, and then once you reach the top, it goes down. And then it reaches bottom and goes back up. So that's an interesting fact, too. Anything that moves in a circle actually makes a wave